example from spherical coordinate systems. Now in this example we want to evaluate the triple integral of x squared plus y squared plus c squared over a domain E, where E is the portion of the ball x squared plus y squared plus c squared less than or equals to 9 in the first octant. Okay. So basically we have the boundary of the ball is a sphere with radius 3. So we have a sphere. Okay. Equation of this boundary of the ball is a sphere with the equation x squared plus y squared plus c squared equals to 9. Then we have this x-axis, y-axis and the c-axis. So basically our domain is the portion of the sphere in the first octant. So probably this part. This is your domain. Okay. Now whenever you see a term like this, x squared plus y squared plus c squared, 99% 9 times use spherical coordinate system. And even here your domain is a part of a sphere. So again this is a hint, we should use spherical coordinate system. Okay, so now let's consider the triple integral. This triple integral becomes in a spherical coordinate system, x squared plus y squared plus c squared equals to rho squared. This part is rho squared. Now dv is the volume element. The volume element in spherical coordinate system should be rho squared sine phi d rho d theta d phi. Next we are going to find the 6 limits. The inner integral corresponds to the rho, so that's the distance. Let's see. So rho goes from 0 to, this is the rho goes from 0 to 1, from origin to the boundary of the sphere, which is 3 theta. Okay, now we want to consider the first octant, and theta goes from 0 to pi over 2. That's your theta angle, 0 to pi over 2. And then angle phi goes from 0 to, so that's the angle phi, again it goes from 0 to pi over 2. Okay, now if you simplify the integrand, you should get rho to the power 4 times sine phi d rho d theta d phi. Okay, now my first variable of integration is rho, therefore we can treat sine phi as a constant. Integral of rho to the power 4 is rho to the power 5 over 5. lower limit is 0, upper limit is 3. Then you have d theta d phi. I forgot to write the sine phi term. So we have sine phi 0 to pi over 2, 0 to pi over 2. Okay. So this quantity is nothing but 3 to the power 5 over 5, and it's a constant. And my next variable of integration is theta. Again, we can treat sine phi as a constant. Basically, you have 1, integral of 1 with respect to the theta variable is theta. If we apply the limit, you should get pi over 2 and finally you have this integral sine phi d phi. Integral of sine phi is minus cosine phi. The lower limit of phi is 0, upper limit of phi is pi over 2. Now we have 3 to the power 5 over 5 times pi over 2, okay, minus cosine pi over 2 minus cosine 0. Cosine pi over 2 equals to 0, so this part is 0, but cosine 0 is 1, so basically inside this parenthesis you have negative 1. Negative 1 times this negative becomes positive, so you have positive 1. Positive 1 times this entire constant give you the same constant. Therefore the answer is 3 to the power 5 over 5 times pi over 2.